Okay, so as I said, my name is George. I'm currently working as an Android developer, software engineer in Amazon. Now I'm working into the Android application of Ring, and before that within Amazon I was working with the Fire TV team, and my team was responsible for two of the biggest TV public broadcaster applications for the Fire TV devices, which is the BBC iPlayer and the All4. So, pretty much, in today's talk, what are we going to hide, first of all? What our applications are comprised of. We have, of course, our source code, any sort of Java or Kotlin source code we have our resources, strings, manifests, values, layouts, images, whatever resource you might have. Of course, it would be better, it would be good if you could indeed hide it. And then, of course, we have any extra modules that we might be working on. You know, make a service, make an application, go to them and actually ask them, please hack our applications, find our vulnerabilities, and then report back to us in order to be ready for production. And then, of course, there's bug bounty. Like, many companies are just like having open bug bounty saying, you know what, if you manage to find any sort of issues with our application, any sort of security flaws, report back to us and you will gain from money to positions in that company. So there is always the white hat type of hacking. So hacking in general is indeed a good thing. It's just how we're actually doing it that matters. All right, so today's agenda, I'm going to split this talk in two categories. First category is going to be offense. So we're actually going to decompile an application live right now. I'm just going to show you how easy it is for someone to just hack your application and find out everything pretty much about it. And then in the second half, I'm going to show you how, like, some steps you can do in order to hide some of your information a little bit better, in order to make it harder and harder for somebody to actually access those sensitive information. So we begin with the offense. As I told you, we're actually going to decompile an application. But before we do that, just so we're all on the same page, when I'm actually going to search through the decompiled application, I'm going to talk through what actually consists of an application. So when somebody just like presses the generate signed APK button on your Android Studio, what happens? First of all, Android Studio takes manifests, resources, assets, and manifests, resources, and assets, yes. And these three things are packaged into the AAPT or packaged bundle. Then all of the resource code of the project is taken. So our resource code, the resource code of any extra modules or any third-party libraries is all taken and bundled together into the bytecode. And then the bytecode and the packaged resources are bundled together again to create the unsigned APK. And just to show you that the APK is not any type of like security measure, it's just a glorified zip. So if anybody has an APK on your computer, feel free to just rename it from .apk to .zip and then try to extract it. You'll see that half of what the app is comprised of is right there. So the APK is pretty much a glorified folder, a compressed folder. Okay, so we have our unsigned APK, and then something really important happens, which is we have our key, and we take this key, we sign our unsigned APK, and then our unsigned APK goes pretty much to the world. It goes to the Play Store, it goes to the internet, it goes to the hands of any sort of hacker that might be there. So the key will play a really important role, and I'm gonna talk more about it later on. Good, so now let's actually decompile an application. So the application I built is this one. It's a pretty simple application. It's comprised of two screens. So the first screen, as you can see, is an image, some text, a button to the next screen, and pressing the button, you see that says, below is my secret key, but you can see it. So you cannot see it. So below this text, there's actually a second line of text, and what we're gonna try to find is what is actually writing right there. So let's do that. I'm going to sit down. And a couple of months ago, when I did this talk again, I had to download and install a couple of command line tools to decompile it. Now there's actually an even easier way. There are extensions for VS Code that they can do all of the work automatically for us. The one I'm using is the APK Lab, and pretty much the only thing I have to do is press Command-Shift-P and select the APK that I have to decompile. And for this talk, I'm going to have to decompile the Java and keep the main classes. So I'm going to leave it for a couple of seconds to do its job. And once everything is decompiled, it's going to open a new window with pretty much everything that there is in this specific APK. Cool. So now let's actually start going through this folder and see exactly what was decompiled and what was hacked. So I'm going to leave the Java source folder for last, and I'm going to go through the rest of them. I think that should be a little bit better now. So first of all, we have a Kotlin folder with just a couple of Kotlin code added by the Android operating system, not really important. There is an original folder, and the first kind of important file that we might find is the manifest, but it's a manifest that's not actually readable. So it doesn't give us a lot of help, so we're going to close it and we're going to keep forward. And we're going to find the manifest, the second manifest right here. And the second manifest, as you can see, it is the actual manifest, 100% the same as the one written by the developer. We're having two We're having two activities. The one is the secret activity, and the second is the main activity. And the main activity, as we can see, is just a launcher. This application is not using any permissions for the Android operating system. That's why there are no permissions at the top. But if the application was using any, they would be still here along with any services or anything else that might be there in the manifest file of the developer. Cool. So now let's move into the original. No, I was into the original, into the resources. And into the resources, we're starting to have the first sort of like real important and real interesting data that we can extract from an APK. So as I told you, the resources are everything packaged into the AAPT file, the packaged resources. So we're having animations, we're having colors, we're having drawables. So in drawables, of course, there are many of Android drawables, but as you can see, I was using a single image in my project. And there it is. I mean, that's actually an image. You cannot see it really well. But there it is, the image I was using in full resolution right there. Now, moving forward, I can see a couple of drawable folders, and I can see a layout folder, which goes more into the code that we're trying to find. And we're having an activity main, which is nothing simple, relative layout with a linear layout, image, two text views, and a button. Pretty much what we saw. And everything is as expected. We're having the titles right there, deobfuscated, and everything's right there. We're having any hard-coded text straight into the layout file. And of course, we're having the activity secret, which was the activity that we were actually trying to figure out some stuff about. And as we can see, there is indeed the first text view that says below is my secret key, but you cannot see it. And then a second text view, exactly as the app implied, but the text says that this is a placeholder. So that's probably not what we're trying to find. And if we look a little bit closer, we're going to see that the reason that we could not see what was there is because the color of the text was exactly the same as the color of the background. All right, so now we're going to try to figure out what's exactly the value of this text view via the code. So I'm going to close the layout file, I'm going to move forward, and I'm going to go to the values. And opening values, I'm going to open strings. The reason I'm doing that is because I want to pretty much show you that I used 3 strings in my project, and I just added the double dash in front just so everything's on the top and easily more findable. But all of the strings that you are using into your Android application, again, they're right there, they're deobfuscated, they can be easily found, they can be easily extracted. So please, if you have anything, even importantly, like even a little bit sensitive, please don't add it into the strings file. So for example, right here, I'm having a hard-coded key, and if somebody got to get my APK, which is really easy, they could be easily find it out. All right, so now let's close the resources folder and let's move into the Java folder, which is the most important one. Again, we're having some Android code, some Android X code for the app compact activity, and some Kotlin and some IntelliJ and JetBrains code from Android Studio, but what we're most interested in is the actual code that the developer built, which is this package. So we're getting the build config. So everything in build config, again, it's right there, not safe, anybody can find it. It's pretty common to have like a constants file within your program. Again, the constants file, all of the strings are right there. They're really easy to be decompiled, so please don't hard code any sort of strings within your Java files. And later on, I'm going to show you some tips on exactly what you can do in those situations. We're having the main activity. There is just a couple of methods. I just want to show you that when we're decompiling everything, we can actually get an extremely close view of what the developer actually wrote. So we're having all of the methods of the names of the methods, what those methods are doing. Of course, for example, right here, I did not write it exactly like that, but you can understand that we're finding the button, we're setting an on-click listener, and then we're running a lambda, and the lambda is this one, which is starting a new activity. Like, it is really close to exactly what the developer intended to write. For example, we can see that I wrote an encrypt something important method that takes a string, splits out the string, but pretty much the only thing it does is that it reverses the string. So again, not really type of encrypting a string or anything. Cool. So now let's open the secret activity, which is actually what we want to do. Secret activity, again, is pretty simple. We're having the text view that we saw before, and then we're setting the text from the constants get AWS secret key. So now, if we go to constants, our AWS secret key is what was actually displayed into the application. So the reason I'm doing all of that is because I want to show you again that once the APK is out in the wild, it's out on the internet, it's up to anybody with enough time, knowledge, and money to pretty much take it, decompile it, and find any sort of sensitive information that might be into their interest. Cool. So now that we saw how easy it is for somebody to decompile our application, let's move forward with the defense part of this talk. And I'm going to stand up again. So what I'm going to do is I'm going to go through various use cases within your applications. I'm going to start with very specific ones, and I'm going to go to more generic that apply to most of the applications. And I'm going to tell you exactly what you could do in order to start being better defended against various attackers. So the first use case is for applications that are using any sort of location data, any sort of user location data into their application. For example, on my team, in the Ring application, I am working with locations. We are in charge of users adding their home. We're in charge of users' geofence. So actually checking for mock locations whenever a user installs and runs our application is really important because it's a really important step to make sure that nobody is actually trying to just mock anything that's running on the operating system. Faking, spoofing the GPS location is super simple for any user. They can just download a couple of really well-known free applications to do that with zero knowledge. But yet again, checking for mock locations is also really simple and really easy. So again, it's something that everybody will be doing if they're using any sort of location data straight into their application. Moving on, this is one of my favorite slides. Pretty much what I want to tell you here is that we will always need to be acting upon every single HTTP response. What I'm talking about. So for example, I'm going to give you an example. I've been guilty of doing that many times. I'm having an HTTP response and I'm doing something like, if the response is what I want, do the happy path, else do nothing, do the show an error or something. But what I'm trying to tell you is what happens in that else scenario. Why did the response fail? Was it a timeout? Was it that the header was missing? Was it that the user was not authenticated? For example, if we are requesting a specific header as a response, and that header is not there for like 5 straight times, 10 straight times, like 20 times within a week, then maybe this MAC address that's giving back the response is an attacker, and we might want to show a different message. We might want to clear our sensitive data. We might even want to blacklist, to black hat this MAC address in order to not even send anything straight to that. So pretty much what I'm trying to tell you is that we should always have a plan on what's happening on those wrong or error HTTP responses. We should not just having like a generic else show error message use case. Again, only in the situation that there is any sort of gains for some attacker to do that. Like if we're having a really simple application that we don't even care, like if it's open on GitHub, we might not need to do all of that stuff. Cool. Now going into, again, more generic use cases, storage. Like local storage is really useful on Android applications. Of course, we need to store various different types of data. So let's see where we can store our data and exactly what are our options and when should we be using each of those options. So we begin, of course, with shared preferences and external storage. So this is pretty much the super simple, unencrypted, deobfuscated way to just store, dump any sort of text that you want. Everything is right there, it's open, there's no need for any key authentication, there's no encryption or anything. Anything you can store there can be easily found, changed, and repackaged back, even without decompiling your application. So if you're having like some sort of settings that save there if the user is a paid user or not, it might be a wise choice to remove it from simple shared preferences, because somebody could just open your shared preferences without even decompiling your application or changing anything into your application, because the shared preferences file is a separate one from your application, change it, and then open your application back again, and maybe they're a paid user, and we don't want that. So pretty much anything that's sensitive or you don't want it to be changed, it should not be stored into external storage or shared preferences. Now, moving on, for all those types of data, we have, of course, encrypted shared preferences. Encrypted shared preferences, as the name suggests, is just encryption above the shared preferences files. There are some specific files called ESP files that are just being encrypted with a specific master key. And pretty much we're allowed to store there anything that is more sensitive or more confidential within our file. Again, we should always practice to not save or save the least amount of data that we need into our application. It's not the best way to just save, like dump everything that you might want into your application. Again, it's not always possible, but if possible, we should be doing that. In encrypted shared preferences, as I told you, there is a specific ESP file, and we should not be using just a single ESP file for all of your projects. We should be using different ESP files based on each use case. So, for example, one ESP file for settings, one ESP file for, I don't know, some passwords, that somebody might have said, a different ESP file for whatever, addresses or whatever. And the reason that we're doing that is because each one of those ESP files will need to have a different key. And what we want to avoid is that if one key is found, then we don't want all of our data to be exposed. We want just a specific use case to be exposed in this application. And then, of course, there's the key store. The key store is provided via the Android operating system, and the key store is pretty much the place that we can just store all of the encryption keys. Encryption keys, of course, is one of the most important parts of any sort of encryption algorithm. Even the most strong encryption algorithm is completely useless if the encryption key is found. So key store is provided by the Android operating system. There is an elevated security clearance in order to store those encryption keys, and we definitely should be using that whenever we want to store something, like whenever we want to store an encryption key straight in there in order to be used later on for any sort of decryption and encryption, or even like the encryption, the encrypted cert preferences. Cool. Now, let's talk about the NDK. Let's talk about some native bytecode. What I told you before is that you should not be hard-coding any of your strings in your applications. Of course, we all know that sometimes that is not possible. Sometimes we need to hard-code a token. We need to hard-code anything. Of course, we should always practice what I told you before. We should try to safely obtain that from any sort of external parameter, like even the internet or someplace else. It should not be hard-coded into the app, but I know, we all know that sometimes we just cannot avoid it. So what should we do back then? If we do need to hard-code something into our application, at least let's not hard-code it straight into the Java or the Kotlin files, or even worse, the resources files. We should be using the NDK. We should be using some native bytecode. The reason we're doing that is because this way we're just adding an extra layer of difficulty for any attacker. Even the native bytecode can still be decompiled, can still be found, but it's just an extra step that if we do absolutely need to hardcode something, we should be using into. And an extra tip is that instead of just hardcoding something into your NDK, it would be much better to actually find some sort of silly algorithm to generate that string. That is just, again, an extra step. We're just trying to add more steps and difficulty to any of the attackers in order to find our data. Next, let's talk about the APK signature check. So, as I told you before, when I showed you what an application is comprised of, there's the key. And the key plays a really important and major role in the whole security of our applications. Why is that? Because the key is the only part of the app that actually remains within our reach. The key is used to sign the application, and then the application goes to the public, but the key remains within us. The user, the attacker, cannot obtain it, cannot get it, and this way they cannot use that key in order to re-sign the application. Because anybody can get your application, they can decompile it, they can change it to do whatever they want, and then they can recompile it back, but the only thing that would be missing is the key that they will use to sign this application, because in order for this application to be used, it needs to be signed. So once they sign this application back again, they're going to have to generate, or they're going to have to use their own key. So what we can do, again, we can use some runtime comparing in order to check the key that was used to sign the app that's running right now, and check it if it matches the expected one. Of course, this is an oversimplified version of the whole thing. You can just retrieve the key that was signed, the hash of the key that was used to sign your application. But of course, the most important part is you need to find a safe way to get the expected key. Because again, this is like there are two parts of the comparison, and the expected key is you need to find a safe way, you need to find a good way to obtain this expected key. And then, of course, if you compare those two, you're definitely going to be able to know that the application that's running right now is the one that you wrote, and not an attacker's code that was decompiled and recompiled back. And closing off, if you have any sort of like super critical algorithm that's going to differentiate you from everybody else, and it's the algorithm that's going to make you money, please don't put it in your application. You can abstract it, you can hide it into your backend, and you can use it as an API. I know that on some use cases, an API is just adding more time, and time is of essence, a user experience sometimes. But again, you should always be thinking of pros and cons of each situation, and if there's something that's really important, really critical, and it's a simple algorithm, maybe it would be better if it was abstracted into a layer of a backend, which again, it's just more secure. It's not out there into the public. And I'm going to close off to tell you that everything that I just told you, all of those defense measures are always relying onto a secure operating system. So as we know, Android OS is an open OS. It can be rooted, and once the OS is rooted, there are a lot of really low-level things that somebody can go and tweak. So if our application is running into a tweaked operating system, then unfortunately, it's not up to us to do a lot of things. On a rooted, on a tweaked operating system, like the location can be mocked without having the, an operation can be mocked without found out, the way I told you about, and responses can be just like spoofed and changed with no problem whatsoever. So pretty much all of what I told you before relies on an operating system. And pretty much I want to tell you again, when I'm closing, that everybody that I just mentioned are just proposed ideas to add more difficulty and time for somebody to just decompile your application. There's no such thing as 100% bulletproof, super safe application. Applications are right there, and they're on the hands of everybody, and with enough time, determination, and money, they can just be decompiled and changed. So pretty much what you should do is you should have a threat model, develop your code against it, and have all of the remediations necessary against that model. Good. That was all from me. So any questions?